Look at almost any apartment building or modern home with a balcony, and then look at how people actually use them. Storage boxes, old bikes, a dying plant. What went wrong? The answer isn't money. It isn't space. It's design. And most people, including most architects, are getting it fundamentally wrong. Today we're going deep into the physics, the history, and the human psychology of the balcony. And by the end of this video, you'll never look at one the same way again. The balcony is one of the oldest architectural inventions humans ever made. In ancient Rome, residents of multi-story insulae, the world's first apartment blocks, built crude wooden platforms jutting from upper floors. They weren't decorative. They were survival infrastructure. Let's start with the most critical, most ignored function of a balcony, shading the wall and window below it. When a balcony is correctly proportioned, deep enough relative to the window height below it, it acts as a permanent, fixed shading device. In summer, when the sun is high, the slab blocks direct solar radiation from hitting the glass. In winter, when the sun is low, light slides underneath the balcony and enters the room naturally. A balcony that is only 30 centimeters deep does almost nothing for shading. A balcony that is 90 to 120 centimeters deep can reduce solar heat gain through the window below by 40 to 60% without any mechanical system. That's free cooling, built into the architecture. The slab itself has another role: thermal mass. Concrete absorbs heat during the day and releases it slowly at night. A south-facing balcony, or north-facing in the southern hemisphere, that is designed to be warm in winter can preheat the adjacent room by 2 to 4 degrees Celsius through this mechanism alone. The second function of a great balcony is something most people never consider. It is a ventilation engine. When wind hits a building, one face experiences positive pressure. It is being pushed. The opposite face experiences negative pressure. It is being pulled. A correctly positioned balcony with a door or window can become the primary intake point for cross-ventilation. The balcony creates a sheltered zone where air slows, cools slightly, and enters the room at a lower velocity, which feels more comfortable on the body. The railing design completely changes this. A solid balcony wall, concrete or brick, creates a zone of dead, stagnant air on the balcony surface itself. An open railing, metal bars, glass with gaps, timber slats, allows wind to pass through and across the floor surface. In hot climates, this distinction is the difference between a balcony you want to sit on and one you avoid. In multi-story homes, a well-designed balcony can feed the stack effect. Warm air rises and exits through high-level openings. The balcony, positioned at mid-level, draws in cooler replacement air from below and outside. This creates passive convection, a continuous airflow cycle with no fan, no electricity, no running cost. Mistake 1. Wrong orientation. A balcony facing west in a hot climate is almost unusable from 2 p.m. to 7 p.m., peak heat hours. Most builders never consider sun path. The balcony is placed where it fits the floor plan, not where it serves the climate. Mistake 2. Too shallow. Anything under 90 centimeters is essentially decorative. You cannot sit on it comfortably, you cannot shade the window below it, and you cannot generate meaningful cross-ventilation from it. Mistake 3. Solid perimeter walls. Installed for privacy or structural simplicity, solid walls trap heat, kill airflow, and transform the balcony into an outdoor oven in summer. Mistake 4. No transition zone. The greatest balconies in history all have a threshold, a moment between inside and outside. Modern apartments open a glass sliding door directly onto a balcony with no eave, no overhang, no transition. When it rains, you retreat inside. When it's harsh sun, you retreat inside. The balcony becomes all or nothing. Mistake 5. No planting. Plants on a balcony are not decoration. A row of potted plants along the edge reduces ambient temperature by 2 to 5 degrees Celsius through evapotranspiration. They also add a soft visual barrier, creating psychological enclosure, the feeling of being in a space rather than on a ledge. Principle 1. Depth. Minimum 120 centimeters for a single chair and side table. 150 to 180 centimeters for two people seated comfortably. Anything less is a decorative ledge. Principle 2. Orientation. In the Northern Hemisphere, face south or southeast for maximum winter sun, morning light, and usable afternoon shade. Avoid west-facing as a primary orientation in hot climates. Principle 3. Overhead cover. At least 50% of the balcony area should be covered by an overhang or roof. This allows use during light rain, blocks harsh noon sun, and creates the psychological shelter that makes people actually inhabit the space. Principle 4. Open railing. Verticals or horizontal slats at 50 to 70% open ratio. Enough visual privacy, enough airflow. Glass can work if set in a frame with open sections above or below. Principle 5. Planting ledges. Build planting ledges into the balcony edge, not as an afterthought. A 20 to 30 centimeters ledge with irrigation allows dense edge planting that filters air, reduces heat, provides privacy, and increases time spent outdoors. The balcony is one of the most powerful passive design tools in residential architecture. It shades walls. It channels air. It extends living space. It reduces cooling loads. And it has been doing all of these things for free in traditional buildings across the world for thousands of years. Modern architecture forgot all of this in the rush to make buildings that photograph well. What we lost was function. And what we called a balcony became a ledge with a railing. If you found this useful, I want to hear from you. What does your balcony look like right now? Drop a photo or a description in the comments. Subscribe if you haven't already. And I'll see you in the next one.